Thank you for choosing to be here tonight. Out of all the places you could direct your attention, you've turned inward, towards something gentle and restorative. As you settle in, perhaps already feeling the softness of the pillow beneath your head or the quiet hum of the room around you, you are entering a state your brain understands deeply. Tonight, we're exploring what happens inside your mind during slow-wave sleep, the deepest and most physically restorative stage of rest. By the end, you'll discover how your brain repairs, reorganizes, and resets itself beneath awareness. You'll understand why this hidden state is not just rest, but renewal. Slow-wave sleep is sometimes called deep sleep. Psychologists and sleep scientists describe it as the phase when the brain's electrical activity moves in long, slow rhythms, known as delta waves. But instead of thinking of it as something abstract or technical, you might imagine it as your brain dimming the lights and locking the doors to the outside world so it can quietly tend to itself. This is not something you have to initiate. It unfolds naturally, guided by systems that have been refining this rhythm for millions of years. Even now, as you listen, your body may already be preparing. Tiny chemical messengers are shifting in balance. Your breathing may be slowing almost imperceptibly. Your thoughts might be losing their sharp edges. All of this is part of a transition the brain rehearses every night. Neuroscientists have found that slow-wave sleep tends to occur more heavily in the first half of the night, when the pressure for rest is strongest. That pressure builds steadily across the day, like an hourglass quietly filling. You might notice that simply hearing about this process begins to soften your awareness. There is something reassuring about knowing that rest is not passive. While you drift, your brain will be active in a different way, not chasing ideas or solving problems, but restoring balance. It is a shift from doing to repairing. So tonight, as we gently explore this hidden world inside you, there is nothing to achieve. No effort required. Just curiosity. Just listening. Just allowing your mind to follow the rhythm of these words as your body prepares for the deeper rhythm waiting beneath them. And now we begin. Slow-wave sleep belongs to a larger architecture that scientists call non-REM sleep. REM, meaning rapid eye movement, is often associated with vivid dreaming and heightened brain activity that resembles wakefulness in certain ways. Non-REM sleep, by contrast, unfolds in quieter stages that gradually deepen. Within this non-REM progression, there are lighter transitional phases, and then the profound descent into slow-wave sleep, the deepest stage, marked by those long, rolling delta waves that sweep across the brain in unhurried rhythm. Delta waves are not abstract signals. They are the collective electrical expression of millions of neurons shifting into a coordinated pattern of activity. Neurons are specialized cells that communicate using small electrical impulses and chemical messengers. During waking life, these cells fire in complex, rapidly changing sequences as you speak, calculate, remember, plan, react, and adapt. The waking brain is beautifully busy, with countless circuits operating simultaneously, often competing for priority. But during slow-wave sleep, something changes. Instead of individual neurons firing in scattered, unpredictable patterns, large populations begin to fire together. Scientists describe this as synchrony. Imagine a vast city at night where lights that once flickered independently now dim and brighten in unified waves. That coordinated rhythm is what EEG recordings detect as delta waves, high in amplitude, slow in frequency, steady and deliberate. This transition is not random. It is governed by two major biological forces working in quiet partnership: circadian rhythm and sleep pressure. Your circadian rhythm is your internal 24-hour timing system. It is regulated by a structure deep in the brain called the suprachiasmatic nucleus, which responds to light cues from the environment. This clock influences hormone release, body temperature, alertness, and sleep timing. Even if you were isolated from clocks, your body would still attempt to follow this internal rhythm. Sleep pressure, on the other hand, is more like a chemical accumulation process. As you move through the day using energy, thinking, walking, interacting, a molecule called adenosine gradually builds up in the brain. Adenosine is a byproduct of cellular energy use. The longer you stay awake, the more adenosine accumulates, increasing the drive for sleep. It does not shout. It gently presses. You might recognize this pressure as the subtle heaviness that appears in the evening, the slight fog behind the eyes, the slowing of reaction time, the natural pull toward stillness. That sensation is not weakness. It is biology signaling readiness for restoration. When slow-wave sleep begins, one of its roles is to help reduce adenosine levels. This clearing contributes to the refreshed clarity you feel in the morning after adequate rest. Caffeine temporarily blocks adenosine receptors, preventing the molecule from docking where it would normally signal sleepiness. This is why coffee can delay fatigue. But it does not eliminate sleep pressure. It only masks its perception. Another essential feature of slow-wave sleep is reduced responsiveness to the external world. During this stage, the brain raises its threshold for awakening. This process, known as sensory gating, allows the cortex, the outer layer of the brain responsible for higher processing, to disengage from unnecessary input. The thalamus plays a central role here. Acting as a relay station for sensory information, it adjusts how much incoming data reaches conscious processing areas. Sounds do not vanish. Sensations do not cease. But most are filtered before they require interpretation. This filtering is protective. It creates an internal environment where restoration can occur without constant interruption. A sudden loud noise can still wake you, but ordinary background sounds lose their urgency. Meanwhile, your autonomic nervous system begins shifting toward parasympathetic dominance. The autonomic system regulates functions you do not consciously control: heartbeat, digestion, breathing. The parasympathetic branch is associated with rest, digestion, repair, and calm internal states. Heart rate slows, blood pressure decreases, muscles loosen. Body temperature begins its gentle nighttime drop. None of these shifts are signs of shutdown. They are signs of recalibration. Interestingly, research shows that slow-wave sleep is more abundant in childhood and adolescence. Young brains display especially strong delta activity. Scientists believe this supports development, learning, and physical growth during early life stages. As we age, slow-wave sleep gradually decreases, though it remains deeply important throughout adulthood. Even more fascinating is the concept of local sleep regulation. Studies reveal that areas of the brain heavily used during the day may show increased slow-wave intensity at night. If you practiced piano for hours, regions involved in motor coordination may exhibit stronger delta activity. If you engaged in intense problem-solving, frontal areas may display deeper, slow oscillations. This suggests that the brain allocates recovery strategically. It knows where effort was spent. It knows where repair is most needed. All of this occurs beneath awareness. You do not initiate the synchronization. You do not consciously lower your blood pressure. You do not instruct growth hormone to prepare for release. Evolution has shaped these systems across millions of years, refining them long before language existed to describe them. And perhaps there is something deeply reassuring in that realization. You do not have to engineer your descent into rest. The process is already unfolding. Even now, as you continue listening, breathing may be softening. Muscles may be releasing tension you did not notice you were holding. Thoughts may be spacing themselves further apart. The threshold between analysis and rhythm is gradually thinning. You are not forcing sleep. You are allowing a system designed for restoration to do what it has always done. And as you move closer to that deeper rhythm, the coordinated waves inside your brain begin to shape something even more intricate. The delicate balance between connection and pruning that defines the architecture of memory. When researchers want to observe the sleeping brain, they often use a tool called electroencephalography, or EEG. Small sensors placed on the scalp detect tiny electrical fluctuations generated by neurons firing beneath the skull. These signals are amplified and translated into waveforms. During wakefulness, EEG readings appear fast, irregular, complex, reflecting the rapid exchange of information between countless neural networks. The waking brain is dynamic and adaptive, constantly responding to sensory input and internal thought. But during slow-wave sleep, the pattern transforms dramatically. The EEG displays large, slow oscillations, delta waves, rolling steadily across the cortex. These oscillations reflect alternating up and down states within neural populations. In the up state, groups of neurons briefly fire together. In the down state, they fall silent. This coordinated alternation creates a rhythm that sweeps across the brain like a tide. The beauty of this system lies in its synchronization. Instead of chaotic firing, networks pulse in unity. Communication becomes structured. Competing signals quiet. The brain shifts from active processing to coordinated recalibration. One major theory associated with slow-wave sleep is synaptic homeostasis. To understand this, it helps to recall what synapses are. A synapse is the junction where one neuron communicates with another. When you learn something new, certain synapses strengthen, meaning the connection between neurons becomes more efficient. Throughout a waking day, thousands of these connections adjust and intensify. This strengthening supports learning and memory. But there is a cost. Maintaining highly active synapses requires energy. If every synapse remained maximally strengthened, the brain would become energetically overwhelmed and less efficient. Slow-wave sleep appears to offer balance. Research suggests that during deep sleep, overall synaptic strength is gently downscaled. Not erased, adjusted. Important, frequently used connections are preserved or even reinforced, while weaker or redundant ones are reduced. Imagine tending a vast forest. If every branch grew unchecked, the canopy would block light and overwhelm the ecosystem. Pruning does not destroy the forest. It protects its health. This pruning process supports efficiency, clarity, and adaptability. By reducing neural noise, the brain maintains its ability to encode new information the following day. Another structure deeply involved in this process is the hippocampus, a small curved region critical for forming new memories. Studies show that patterns of neural activity experienced during the day can replay during slow-wave sleep. These replays are often compressed, occurring more rapidly than the original experience. This replay is not conscious reliving. It is subtle reactivation, a neural rehearsal that may help transfer information from temporary hippocampal storage to more distributed cortical networks. Over repeated nights, memories become less dependent on the hippocampus and more integrated into the cortex. This transition supports long-term stability. Communication between the hippocampus and cortex during slow-wave sleep appears highly coordinated. Slow oscillations in the cortex align with bursts of activity known as sleep spindles, brief rhythmic bursts generated in part by thalamic circuits. These spindles may facilitate memory consolidation by coordinating timing between regions. Scientists are still refining the exact mechanisms. Sleep research evolves continuously, with new imaging technologies and experimental designs revealing increasing nuance. But the broad pattern remains consistent across decades of studies. Slow-wave sleep supports neural reorganization and stabilization. During this state, overall brain metabolism decreases. Energy consumption lowers. Cells gain opportunity to restore ionic gradients, the delicate balance of charged particles that allow electrical signaling to occur. Without this restoration, neurons would gradually lose responsiveness. The rhythmic alternation between activity and silence during slow-wave sleep allows recalibration at the cellular level. The thalamus continues its role in sensory gating, limiting external interference. Meanwhile, large-scale networks pulse in harmony rather than competition. The result is not emptiness, it is coherence. As these synchronized waves travel across your cortex tonight, they are participating in a process older than language. They are refining the architecture of your thoughts. They are protecting essential connections while trimming excess. They are preserving the lessons that matter and loosening the ones that do not. And all of this unfolds without conscious supervision. There is something quietly profound about that. While you release effort, while sentences blur into softer impressions, your brain continues its intricate choreography. In the next section, we will explore how this deep rhythm influences memory in even greater detail, how experiences transform overnight, how learning stabilizes, and how clarity emerges from unseen rebalancing. For now, simply notice the idea itself, slowing your awareness. Large waves. Coordinated pulses. Silence between signals. The architecture of repair has already begun. As slow-wave sleep settles into its full depth, your brain begins what researchers often describe as a kind of internal night shift. A period of quiet but highly coordinated labor during which the experiences of the day are revisited, reorganized, and gently reshaped. This process does not resemble conscious review. You are not replaying your day in narrative form. Instead, clusters of neurons that were active during specific experiences begin to reactivate in subtle patterns that echo the original activity. In laboratory studies, neuroscientists observing the hippocampus, the structure central to forming new memories, have detected sequences of neural firing during slow-wave sleep that resemble patterns recorded during earlier learning. These sequences often replay at a much faster rate than they originally occurred, compressed into brief bursts, aligned with the slow oscillations sweeping across the cortex. It is as though the brain is rehearsing what it encountered, not to relive it, but to strengthen and integrate it. Memory consolidation is the term psychologists use to describe this transformation. During the day, experiences are encoded in fragile, temporary networks. The hippocampus acts almost like a temporary staging area, rapidly binding together sensory details, context, and meaning. But these newly formed networks are delicate. Without reinforcement, they can fade. Slow-wave sleep appears to support the gradual transfer of these memories from hippocampal dependency to broader cortical networks. Over time, often across multiple nights, information becomes less reliant on the hippocampus and more embedded in distributed neural circuits. This transition supports long-term stability and easier retrieval. For example, when you learn a new concept, the first recall may require effort. You may feel yourself reaching for it. After several nights of sufficient sleep, that same information often becomes more accessible, as though it has settled into place. Studies repeatedly show that individuals allowed adequate deep sleep after learning tend to perform better on recall tests compared to those whose slow-wave sleep was disrupted. But consolidation is not simply strengthening. It is also refinement. Throughout a waking day, your brain absorbs more information than it can permanently retain. It registers countless details, many trivial, some meaningful. If every detail were preserved equally, your cognitive system would become saturated with noise. Slow-wave sleep appears to assist in selecting what is important and allowing less relevant connections to weaken slightly. This selective downscaling supports clarity. It is not erasure in the dramatic sense. It is gentle prioritization. Researchers studying synaptic homeostasis propose that slow oscillations during deep sleep reduce overall synaptic strength just enough to maintain efficiency, while preserving the patterns that were most salient or repeatedly activated. This process prepares the brain for new learning the following day by preventing overload. Interestingly, slow-wave sleep has also been associated with insight. In certain experiments, participants tasked with learning complex problem patterns were more likely to discover hidden rules after a period of sleep. Scientists suggest that the reorganization occurring during slow-wave sleep may allow distant neural networks to link in new ways, supporting creative problem-solving. It is important to note that sleep does not guarantee epiphanies. The brain does not solve every puzzle overnight. But the structural rebalancing that occurs during deep sleep appears to create fertile ground for clearer thinking and flexible associations. Energy regulation also plays a role in this night shift. Neurons are metabolically demanding cells. Throughout the day, their activity consumes glucose and oxygen at high rates. During slow-wave sleep, overall metabolic demand decreases. Brain regions associated with executive functions, planning, decision-making, focused reasoning, show reduced activity. This decrease is not impairment, it is restoration. By lowering overall metabolic intensity, the brain allows cells to replenish molecular resources, restore ion gradients, and repair minor structural stress accumulated during waking activity. It is a recalibration at both the network and cellular levels. Some research suggests that even the intensity of slow-wave activity reflects how much effort was exerted during the day. After periods of intense learning or physical training, certain cortical regions may exhibit stronger slow-wave amplitude, as if the brain is directing deeper recovery toward areas most taxed. The night shift is not chaotic, it is strategic. While you lie still, unaware of the complexity unfolding beneath your skull, experiences are being curated. Patterns are being strengthened or softened. Networks are being tuned for efficiency. And this cognitive refinement does not occur in isolation. Memory is not purely factual. It is emotional, contextual, embodied, which means that as neural circuits reorganize, emotional tone is subtly recalibrated as well. The brain does not only remember what happened, it remembers how it felt. And during slow-wave sleep, that emotional layer begins to soften. Emotions are not abstract forces floating independently within you. They are patterns of coordinated activity across multiple brain regions, including the amygdala, the prefrontal cortex, the hippocampus, and interconnected networks that process bodily signals. The amygdala is particularly involved in detecting emotionally significant events, especially those associated with threat or urgency. The prefrontal cortex helps interpret and regulate those signals, placing them in context. During waking hours, these systems operate in constant dialogue. If something stressful occurs, the amygdala may activate quickly, increasing alertness and preparing the body for action. The prefrontal cortex can then assess whether the response is proportional or needs adjustment. When sleep is insufficient, research consistently shows that this balance becomes less stable. Studies using brain imaging techniques have found that sleep deprivation can lead to heightened amygdala reactivity, meaning emotional responses may feel sharper, more reactive, or harder to regulate. Communication between the amygdala and prefrontal cortex can become less coordinated. Slow-wave sleep appears to support the restoration of this balance. During the early part of the night, when slow-wave sleep is most concentrated, levels of cortisol, often called the stress hormone, tend to decline. Cortisol plays important roles in metabolism and alertness, but elevated levels at night can interfere with restorative processes. Lower nighttime cortisol creates a biochemical environment conducive to neural recalibration. Researchers suggest that emotional memories may be reactivated during sleep in a neurochemical context different from wakefulness. Certain activating neurotransmitters that are high during alert states are reduced during deep sleep. This altered environment may allow emotional experiences to be processed without the same intensity of physiological arousal. In simpler terms, sleep may help separate the memory of an event from the sharpness of the feeling attached to it. You may have experienced this shift personally. A difficulty that felt overwhelming late at night may appear more manageable in the morning. While perspective and daylight both play roles, the recalibration of emotional circuits during sleep likely contributes. Slow-wave sleep does not erase painful experiences. It does not rewrite history, but it may gently reduce the charge associated with those experiences, making them easier to integrate into broader understanding. Mood regulation is also linked to immune and inflammatory processes. Emerging research suggests that adequate deep sleep supports immune balance, and immune signaling molecules can influence mood states. Although this field continues to develop, consistent findings show associations between sufficient slow-wave sleep and greater emotional resilience. Chronic reduction in deep sleep has been correlated with increased vulnerability to mood disturbances. Conversely, improving sleep quality often supports broader psychological well-being. Scientists are careful not to oversimplify this relationship. Emotional health is complex and influenced by many factors, but the pattern remains clear. Deep sleep contributes to emotional steadiness. Another subtle aspect of emotional reset involves memory integration. During slow-wave sleep, as factual memories are reorganized, their emotional context is also adjusted. The hippocampus, amygdala, and cortical regions engage in coordinated activity that may help place experiences into larger narratives. When an event becomes integrated into a broader story, it often feels less overwhelming. It becomes one chapter rather than the entire book. As your brain prepares for slow oscillations tonight, stress-related circuits are gradually quieting. Signals that felt urgent earlier in the day lose intensity. Communication between emotional centers and regulatory networks becomes more harmonious. Breathing slows. Heart rate steadies. Muscles soften. There is a physiological kindness built into this design. The emotional reset is not dramatic. It is incremental. It unfolds night after night, adjusting tone, refining perspective, supporting balance. While you drift deeper, networks associated with vigilance reduce their firing. Neurotransmitters that maintain high alertness decrease. The internal alarm quiets. And as emotional intensity softens, the body joins this recalibration. Hormonal pulses shift. Immune cells circulate differently. Cardiovascular rhythms synchronize with neural oscillations. The mind and body do not operate separately here. They enter coherence. In the next section, we will move into that whole-body coordination, the harmonized interplay of hormones, immune function, metabolism, and cellular repair that accompanies slow-wave sleep. For now, simply allow the idea of softening to settle. Yesterday does not need to be solved tonight. It is being gently reorganized beneath awareness. The night shift continues. Slow-wave sleep is often described in terms of brain waves, neural synchrony, and memory consolidation. But it is equally a full-body event, a coordinated physiological symphony in which nearly every major system shifts into a state of recalibration. The brain may guide the rhythm, but the body follows with profound responsiveness. One of the most well-documented changes during deep sleep is the release of growth hormone. Despite its name, growth hormone is not solely about height or adolescence. In adults, it plays a central role in tissue repair, muscle maintenance, bone density support, metabolic balance, and cellular regeneration. Research shows that the most significant pulses of growth hormone typically occur during the first episodes of slow-wave sleep, especially in the earlier part of the night when delta activity is strongest. This release is not random. It is synchronized with the slow oscillations of the brain. As cortical networks enter those coordinated up and down states, the pituitary gland responds with hormonal pulses that ripple through the bloodstream. Growth hormone stimulates protein synthesis, encouraging cells to repair microscopic wear accumulated throughout the day. Even ordinary movement, walking, typing, standing, creates subtle strain within tissues. Muscles experience micro-tears. Connective tissue adjusts to load. Immune cells respond to minor inflammation. During waking life, these processes are balanced by ongoing repair. but slow-wave sleep provides optimal conditions for more focused restoration. In this state, energy is redirected inward. Your immune system also enters a rhythm of recalibration. Studies have shown that certain immune cells, including T cells, become more active during sleep. Cytokines, small signaling proteins involved in immune communication, display circadian fluctuations, with some peaking during nighttime rest. Although the immune system operates continuously, deep sleep appears to enhance its efficiency and coordination. Research suggests that sleep supports immune memory, helping the body recognize and respond more effectively to pathogens encountered previously. This does not mean a single night of sleep prevents illness, but consistent deep sleep strengthens resilience over time. Metabolism shifts as well. During slow-wave sleep, overall brain glucose consumption decreases compared to wakefulness. Reduced metabolic demand allows cells to replenish energy reserves and restore chemical gradients necessary for electrical signaling. Ion balance, the distribution of sodium, potassium, calcium, and chloride across neuronal membranes, is carefully maintained. The rhythmic silence between neural firing during slow oscillations gives these systems time to recalibrate. Breathing becomes slower and more regular, guided by brainstem centers that regulate respiratory rhythm without conscious effort. Heart rate decreases and blood pressure falls. These changes reflect increased parasympathetic nervous system activity, the branch associated with rest, digestion, and recovery. Parasympathetic dominance supports digestive processes, nutrient absorption, and internal maintenance. It is the physiological opposite of fight-or-flight activation. When parasympathetic tone rises, stress hormones decline, muscle tension eases, and internal systems prioritize repair. Muscle tone during slow-wave sleep is reduced but not entirely suppressed, as it is during REM sleep. Instead, there is a stable relaxation, a heaviness that signals safety. Motor circuits quiet. Signals preparing the body for action diminish. The sensation you experience as weight in your limbs is partly the reflection of this neural disengagement from readiness. Temperature regulation also plays an essential role. Core body temperature gradually declines in the evening as part of the circadian rhythm. During slow-wave sleep, it often reaches one of its lowest points. This cooling supports metabolic efficiency and is associated with deeper sleep intensity. Blood vessels near the skin dilate slightly, allowing heat to dissipate. That subtle warmth in your hands or face can be a sign of this heat exchange occurring. Even blood flow patterns in the brain adjust. Regions associated with executive functions, planning, focused reasoning, self-monitoring, show decreased activity. This corresponds with the subjective fading of analytical thought. At the same time, other networks pulse rhythmically in coordination with slow oscillations. All of these processes are synchronized. The slow waves of the cortex align with hormonal pulses. Hormonal pulses influence immune signaling. Immune signaling interacts with metabolic regulation. Cardiovascular rhythms harmonize with neural oscillations. It is not a series of isolated events. It is a choreography refined across evolutionary time. There is intelligence embedded in this design, not in a mystical sense, but in the sense of systems optimized through adaptation. Organisms that rested effectively survived and reproduced. Over millions of years, sleep architecture became increasingly structured and purposeful. As you lie still, perhaps already feeling the gentle weight of gravity more fully against your body, your internal systems are preparing for this coordinated descent. The quiet inside you is not emptiness. It is preparation for repair. Nothing dramatic announces the transition. It happens gradually, in layers. First, the softening of breath. Then, the easing of muscle tone. Then, the narrowing of sensory gating. Then, the widening of slow oscillations. You do not need to initiate these changes. They are emerging on their own. And as the body enters deeper stillness, your subjective experience begins to shift as well. As slow-wave sleep approaches, there is often a subtle but noticeable shift in how you experience your own body and mind. The transition rarely arrives with sudden clarity. Instead, it unfolds gradually, like dimming light at dusk. You may begin to notice heaviness in your arms or legs. This sensation is partly due to reduced motor cortex activity. During waking life, the motor cortex continuously sends preparatory signals to muscles, even when you are still. It keeps the body ready for movement. As non-REM sleep deepens, these preparatory signals decrease. The body no longer needs to remain on standby. That heaviness is not weakness. It is release. Breathing changes next. Respiratory centers in the brainstem adjust rhythm as alertness declines. The breath becomes slower, deeper, more rhythmic. You may notice the exhale lengthening slightly. This is not something you consciously control. It is the parasympathetic system guiding respiration towards stability. As breathing steadies, heart rate follows. The heart does not simply slow randomly. It aligns with autonomic rhythms shaped by circadian timing and neural oscillations. The steady pulse beneath your chest reflects a body no longer preparing for immediate action. Sounds in the room grow distant. The hum of electronics, distant traffic, subtle environmental noise, all continue, but your brain interprets them differently. The thalamus modulates sensory transmission so that only salient signals are prioritized. The brain decides most sounds do not require response. This filtering creates space. Thoughts begin to lose coherence as well. During wakefulness, the default mode network, a constellation of brain regions active during self-reflection and mind-wandering, frequently engages. It constructs narratives, replays conversations, anticipates outcomes. As slow-wave activity increases, activity in this network decreases. Sentences become fragments. Fragments become impressions. Impressions dissolve. Time perception shifts. Without active frontal monitoring, moments feel less structured. You may not track the passage of minutes clearly. This blurring reflects reduced coordination between regions responsible for sequencing and awareness. There can be brief sensations of floating or falling just before deeper sleep, what scientists call hypnic jerks or hypnagogic sensations. These occur as motor systems disengage and sensory integration shifts. They are common and generally harmless. They reflect transitional neural adjustments rather than disturbance. Warmth may spread across the body as peripheral blood vessels dilate. Skin temperature rises slightly as core temperature drops. This redistribution supports thermoregulation and is often associated with comfort. The boundaries of the body can feel less sharply defined. Neural maps representing bodily position become less active as sensory integration decreases. The sense of where I end and the room begins softens. All of this unfolds without effort. You are not manufacturing sleep. You are yielding to it. Neurotransmitters associated with vigilance, such as norepinephrine and serotonin, decrease in activity during deepening non-REM sleep. These chemicals help maintain alertness and focused attention during the day. As their levels decline, the sharpness of perception fades. The internal alarm quiets. The analytical mind loosens its grip. What remains is rhythm. Beneath your awareness, slow oscillations sweep across cortical networks. Hormones pulse in soft waves. Immune cells adjust signaling patterns. Synapses recalibrate strength. Cerebrospinal fluid begins circulating more freely through microscopic channels. You may not feel any of this directly, but you may feel the overall effect, a sense of surrender that does not feel forced. Letting go is not something you achieve. It is something that happens when the conditions are right. And tonight, the conditions are forming. Breathing softens. Muscles release. Awareness thins. The descent is steady and kind. In the next section, we will move even deeper, into the metaphorical ocean beneath thought, where slow-wave sleep becomes less something described and more something felt. For now, allow the body to continue its quiet alignment. Nothing is required. Everything necessary is already underway. Slow-wave sleep can be imagined as an ocean beneath the surface of thought. Vast, steady, rhythmic, and patient. During the day, your mind resembles wind moving across water. Thoughts ripple quickly. Attention shifts. Sensory impressions sparkle and disappear. Decisions rise and fall like small waves responding to invisible currents. But as night deepens, that wind gradually settles. The surface becomes less restless. Beneath it, something immense has always been there. Depth that does not depend on motion. Neuroscientists describe the slow oscillations of deep sleep as traveling waves. These waves do not remain confined to one small region. They begin in localized areas of the cortex and move across it in coordinated sweeps, sometimes front to back, sometimes side to side, forming patterns that repeat with remarkable consistency. These waves are measurable. They are observable. They are not imagined metaphors. And yet, their subjective experience is simply quiet. When large populations of neurons enter synchronized up and down states, they create alternating periods of brief activation followed by silence. This silence is not emptiness. It is restoration. During these down states, neurons reduce firing long enough to rebalance ion concentrations across their membranes, the delicate gradients that allow electrical signaling to occur in the first place. Electrical activity requires precise chemical conditions. Sodium, potassium, calcium, chloride. These charged particles must be positioned correctly inside and outside each neuron. Over hours of waking activity, gradients shift and require recalibration. The rhythmic silence of slow-wave sleep gives cells space to restore these balances. You do not feel ionic gradients adjusting. You feel heaviness. You feel quiet. But within that quiet, chemistry is harmonizing. There is also increasing evidence for the activity of the glymphatic system during deep sleep. The glymphatic system is a network that facilitates the movement of cerebrospinal fluid through microscopic channels surrounding brain cells. During wakefulness, these channels are narrower. During sleep, particularly deep non-REM sleep, they appear to widen slightly, allowing fluid to circulate more freely. This circulation supports the clearance of metabolic byproducts that accumulate during active waking hours. Proteins and waste molecules are gently carried away through these fluid exchanges. Research in this area continues to evolve, but findings consistently suggest that deep sleep enhances this internal cleansing process. Imagine soft tides moving through hidden passageways. Not forceful waves, not dramatic surges. Gentle, persistent flow. The brain, despite its small size relative to the body, consumes a significant portion of the body's energy during waking life. Byproducts of this energy use must be managed. Deep sleep creates conditions where clearance is more efficient. Meanwhile, connectivity between certain high-level cortical areas decreases. The networks that integrate sensory input, autobiographical memory, and self-reflection loosen their coordination. Without constant integration, the narrative sense of "I am thinking" fades. Consciousness does not disappear completely. It shifts. Psychologists describe consciousness as existing along a spectrum rather than an on-off switch. In slow-wave sleep, conscious content is minimal. Awareness of the external world diminishes. Internal narrative quiets. But fundamental physiological processes continue with remarkable precision. You are not absent. You are deeply resting. And this resting is structured. Sleep unfolds in cycles across the night. Typically, these cycles last around 90 minutes, moving between lighter non-REM stages, slow-wave sleep, and REM sleep. Slow-wave sleep tends to dominate the earlier cycles, especially in the first half of the night when sleep pressure is strongest. As adenosine levels decline and circadian timing shifts, slow-wave episodes gradually shorten, making space for other stages. This cyclical architecture ensures that different forms of restoration occur in balanced proportions. Slow-wave sleep lays the foundation. REM sleep integrates emotional memory in different ways. Lighter, non-REM stages provide transitional bridges. Together, they form a repeating pattern that continues until morning light begins to influence circadian signaling again. There is a quiet trust built into this structure. Even if your day felt chaotic, even if your thoughts seemed scattered, the descent into slow oscillations introduces order. Neural noise decreases. Synchrony increases. Hormones pulse according to ancient timing. Immune cells coordinate their signaling. Cardiovascular rhythms steady into predictable cadence. You may notice now that language itself is softening. Sentences stretch longer. Pauses widen gently. This mirrors the slow oscillations beneath thought, rising, falling, resting, repeating. There is nothing to solve here, nothing to analyze. The science you have heard tonight does not require memorization. It is not instruction, it is reassurance. Your biology is designed for renewal. As you drift further, imagine those delta waves sweeping across your cortex like slow tides across sand. Imagine neurons entering brief silence between pulses, restoring their sensitivity. Imagine cerebrospinal fluid flowing through expanded pathways, carrying away what no longer serves. Imagine growth hormone rising and falling in soft surges through your bloodstream. immune cells adjusting their communication, muscles repairing microscopic fibers, ion channels recalibrating. All of this is happening without effort. If a thought surfaces now, a fragment of memory, a drifting image, it can float briefly at the surface of that ocean. It does not need to anchor. It does not need to become narrative. It can dissolve back into depth. The deeper current remains steady. Slow-wave sleep is not dramatic. It is not vivid. It is not loud. It is steady. It is foundational. It is the quiet repair that makes tomorrow possible. Each synchronized oscillation is a gentle recalibration of the architecture that supports thought, emotion, memory, and movement. Each cycle reduces neural noise and preserves what matters. Each pulse aligns systems that function without your conscious oversight. There is safety in that rhythm. There is intelligence in that design. Your breathing now may already be aligning with slower patterns. Your chest rising and falling with less urgency. Your jaw perhaps unclenching slightly. Your shoulders sinking more fully into whatever surface supports you. The edges of awareness soften. The room becomes distant. Internal and external boundaries blur. Beneath thought, beneath effort, beneath the surface waves of the day, there is an ocean of slow oscillations waiting. Not demanding, not forcing, simply present. And you are already entering it. There is no rush. The descent is gradual. Even if you remain partially aware of these words, deeper systems are continuing their work. Neurons synchronize, hormones pulse, immune networks recalibrate, metabolic waste clears, synapses adjust their strength with quiet precision. Nothing is wasted. Nothing is random. This rhythm has been practiced for millions of years across countless generations of living beings. Long before language described it, slow-wave sleep was already refining neural circuits in the dark. Tonight, it is doing so again. You do not need to monitor it. You do not need to guide it. Let your breathing follow its own tide. Let your muscles release their final fragments of tension. Let your awareness thin at the edges until it resembles mist above still water. The ocean beneath thought is wide. It is patient. It does not hurry. And as you sink further into that depth, your brain continues its ancient choreography, synchronizing, clearing, recalibrating, stabilizing, beneath awareness. Tomorrow will rise from this quiet foundation. But for now, there is only rhythm, only softness, only the steady pulse of slow waves carrying you gently inward. As the night continues unfolding around you, slow-wave sleep does not remain constant from beginning to end. It arrives in powerful waves earlier in the night, when sleep pressure is strongest, and then gradually recedes in later cycles. But even as it lessens in duration toward morning, its influence lingers. Sleep moves in repeating cycles, typically around 90 minutes in length, though this can vary from person to person. Within each cycle, the brain transitions through lighter non-REM stages, descends into slow-wave sleep, then eventually rises toward REM sleep before beginning the process again. The first cycles of the night often contain the deepest slow-wave activity. This is when delta waves are most pronounced, when growth hormone pulses most strongly, when synaptic recalibration is most robust. As adenosine levels decline through the clearing processes of sleep, the intensity of slow-wave activity naturally decreases in later cycles. This design is not accidental. It reflects a biological prioritization. The heaviest restoration happens first, when pressure for it is greatest. Later in the night, REM sleep becomes more prominent, supporting other forms of emotional and cognitive integration. But the foundation laid by slow-wave sleep earlier allows those later stages to unfold more effectively. You can imagine it like tending soil before planting. The deep tilling occurs first. The soil is aerated, cleared, nourished. Only then can more delicate processes take root. If you briefly stir between cycles, that too is natural. Most people experience small awakenings during the night, often lasting only seconds, sometimes so brief they are not remembered. The brain checks its environment, adjusts position, then returns to rhythm. This micro-awakening pattern reflects resilience, not disruption. Even when sleep feels imperfect, the architecture of cycles continues beneath perception. And if your sleep tonight includes more or less slow-wave activity than average, that too falls within normal variation. The body adapts dynamically. After nights of reduced sleep, the brain often increases slow-wave intensity the following night in a phenomenon known as rebound. It compensates when possible. There is flexibility built into this system. You are not fragile here. The night knows how to move in cycles. Though we are not yet at morning, it is comforting to understand how this depth eventually gives way to light. As circadian rhythms shift toward dawn, cortisol levels naturally begin to rise again, preparing the body for alertness. Body temperature gradually increases. Neural networks associated with attention and executive function slowly regain coordination. The transition from slow-wave sleep to wakefulness is not abrupt when the cycle is complete. It is gradual, like light filtering through closed curtains. Because slow-wave sleep has recalibrated synaptic strength, cleared metabolic byproducts, restored ion gradients, and supported hormonal balance, the brain awakens with renewed capacity. Clarity in the morning is not magic. It is the cumulative effect of thousands of synchronized oscillations, millions of neurons entering and exiting silence in coordinated rhythm, hormones pulsing in alignment, immune cells communicating in balance. Even emotional tone upon waking often reflects the recalibration that occurred overnight. The amygdala's reactivity is tempered. Prefrontal regulation is strengthened. Memory networks are reorganized. The mind feels subtly reset. Not empty. Not blank. But steadier. This is why rest is not passive. It is foundational. Tomorrow's cognition, mood, and resilience rise directly from tonight's depth. And yet, for now, tomorrow does not need attention. You are still descending. Perhaps the most remarkable aspect of slow-wave sleep is how little conscious participation it requires. You cannot will your neurons into synchronized oscillation. You cannot command growth hormone to pulse. You cannot manually widen glymphatic channels. And you do not need to. The architecture of slow-wave sleep was refined long before human language, long before analytical thought, long before conscious self-reflection. It is embedded in mammalian biology. It is written into the rhythmic firing patterns of cortical neurons and the circadian pacing of hormonal systems. There is a quiet humility in that realization. You are supported by systems older than your thoughts. Even if the day felt demanding, even if mental noise felt loud, even if stress seemed persistent, the descent into slow-wave sleep does not require perfection. It requires allowing breath to soften, allowing muscles to release, allowing thoughts to drift without pursuit. Slow-wave sleep does not respond to force. It responds to conditions, and conditions are already forming. The room is quieter. Your body is heavier. Awareness is thinner. Neurotransmitters of alertness have decreased. Parasympathetic tone has increased. Delta oscillations are strengthening. Even now, parts of your brain may already be entering brief synchronized down states, dipping momentarily into silence before rising again. These micro-descents are precursors to deeper immersion. You do not need to notice them. They are happening regardless. As the words continue to soften, imagine the surface of your mind growing smoother still. No urgency. No requirement to follow each sentence. Meaning can fade now. Only rhythm remains. Picture those slow delta waves, broad, unhurried, traveling across the cortex like long swells beneath moonlight. Each wave rises gently, neurons firing in coordinated unity. Each wave falls into silence, giving cells space to restore their electrical balance. Up state, down state, rise, rest, rise, rest. Between those oscillations, microscopic channels allow cerebrospinal fluid to circulate more freely, washing through spaces between neurons, carrying away metabolic remnants of the day. Growth hormone pulses quietly. Immune signals recalibrate. Synapses adjust their strength with precise moderation. Heart rate steadies. Breathing deepens. Muscles soften further. Even the small muscles around your eyes release. The jaw loosens. The tongue rests gently. Shoulders sink. Hands grow warmer. Feet heavier. Awareness narrows like a beam of light dimming gradually. If a thought tries to form, it does not need completion. It can dissolve halfway through. Sentences do not need endings. Images do not need clarity. You are not here to understand. You are here to descend. Slow-wave sleep is not dramatic. It is not vivid. It is vast. It is the quiet repair beneath cognition. It is the recalibration beneath emotion. It is the restoration beneath effort. And it is already welcoming you. Each breath now may feel like a tide pulling slightly inward, then releasing gently outward. No control required. The body knows. The brain knows. The ancient rhythm continues whether or not you attend to it. There is nothing to achieve, nothing to fix, nothing to solve tonight. The architecture of repair is unfolding beneath awareness. Neurons synchronize. Ion gradients rebalance. Hormones pulse. Immune cells adjust. Cortical networks reorganize. Memory stabilizes. Emotion softens. Waste clears. Energy restores. And all of it happens in darkness, in safety, in silence. If the room around you fades completely, that is natural. If awareness drifts in and out, that too is natural. The ocean beneath thought does not rush. It simply holds. You are suspended within cycles older than language, supported by systems that have practiced this descent every night of your life. There is safety in that repetition. There is trust in that design. The final fragments of muscle tension release. Breath steadies into quiet rhythm. Edges of awareness dissolve like mist at dawn. Except this is the opposite direction, moving not toward light but toward depth. Slow oscillations widen. Silence lengthens between pulses. The night shift continues without commentary. You do not need to witness it. You are within it. And as the final layers of thought loosen and fall away, you drift fully into the steady, patient ocean of slow wave sleep, where restoration unfolds, where recalibration continues, where tomorrow is quietly prepared, and where you are already resting.